All right, now the next one, we determine the rate of reaction. Determine the rate of reaction, 7 molar concentration when it changes during a reaction to 0 moles. So our final is 0. Our initial is 7 molar. And our final time is 60, that's 180, 193 seconds, minus 0, our initial time, equals, so we have negative 7 over 193 equals, divided by 193 equals negative, oh, both of these are negative, negative 0.036 molarity per second. And basically what that negative means, what the negative number means, is that this is disappearing, right? It's disappearing. I started at 5 and I end at 1.5. I start at 7 and I end at 0. All this negative means is that it's disappearing at 0.036 molarity per second. That's all that negative means. If it was positive, that means it would be a product and it would be appearing at this rate. Okay, name each quantity. Q. Okay, what do they want me to name? I can name it. Q is heat energy. C is specific heat. Tell you what, why don't we just add the units to joules, and this is joules per gram per degree Celsius. And this is a mass in grams, and this is a change in temp in degrees Celsius. Okay, so we've named all that. Now they've given us some problems using this equation. So let's figure out what we have. We have 435 joules, so that's my Q. 435 joules equals. And we have a mass, 3.4 grams. Lovely. Times, and we have at 21 was increased to 85, so we have a delta T, which is 64 degrees. That's just 85 minus 21 is 64 times, and we have X for C, or let's not make it X, let's make it C. We're trying to find C here. Okay, which is good because that's the specific heat. All right, so what do? We take 3.4 times 64 equals 217.6, and then we do 435 divided by second answer equals 1.99. Our specific heat is 1.99. C equals 1.99 joules per gram per degree centigrade. How many joules are contained in 250 big C? Big C. Okay. This is interesting. All right. So there are 4.184 joules per little c. There are 1,000 little c's, so let's do it as a dimensional analysis here. We've got 250 big calories. And in each big calorie, there's 1,000 little calories. And then we have in each little calorie, there is 4.184 joules. So it just seems like multiplication straight across, right? 250 times 1,000 is 250,000, obviously, times 4.184 equals 1 million. 46,000 joules. Okay. End of page 2. Wow, this is short. And here we are. Hess's law. So I told you that you're just adding these two enthalpies. That's what this is, this delta H. So if I add negative 566 plus negative 180.6 equals, and so I just want you to enter this in the calculator, but be very careful. So we're doing negative, the negative symbol right here, negative, right? 566 plus, and then I'm going to do another negative 180.6 equals negative 746.6. We see how we got that? Negative minus a negative, which is just a negative, subtracting this number from a negative, is negative 746.6. Okay, determine if the following are endo or exothermic. All right, so I'm going from a solid to a liquid. So let's do our chart here. Okay, so this is where my solids are, solid. This is where my liquids are, liquid. This is where my gases are, gas. And these are our phase changes, right? Phase change. Phase change. Okay, so when I go from a solid to a liquid, so I'm going from here to here. And let's think about water, or we'll use water. If it's ice and I want to turn it to a liquid, do I have to add energy? Absolutely, I have to add energy into the system. Endo. Gas to a liquid, so I'm going backwards. I'm going from a gas to a liquid. So I know I have to add energy to get from a liquid to a gas, so that's endo. So the opposite way is exo. All right, negative delta H. A negative delta H is exo. Hopefully by now you understand why, but if you don't, let's just go through a quick little discussion. So when we're determining enthalpy, we are subtracting products minus reactants. So let's say that this is 10 joules and this is 90 joules. And it's products minus reactants. Delta H equals products minus reactants. So this would be 10 minus 90 equals negative 80. So the delta H is negative. It's also exothermic. Yes, we know this because we start with this much energy, 90 joules, and we go way down here to this much energy, 10 joules. Where did that energy go to? That energy left as heat. So this is exothermic, right? Exothermic. Exothermic. So you can logic it out however you want, but negative delta H is exothermic. All right, so energy is a reactant. All right, so if it's a reactant, that means we're adding it in. That means it is endothermic. If energy is released, then it's a product, then it is exothermic. Okay, the one that everybody hates. To get more gas into a solution, you must decrease temperature and increase pressure. Okay, we got to go back here to the solubility chart. Actually, if we had our, okay, solids as temp rises, sorry, grams temp, what am I doing? Grams of solubility. This is temperature, temp. So as temp goes up, the solubility of solids goes up. All the curves we've looked at for solids were like this and like this. And then there's one lonely one that looks like this. It looks like this. and that's a gas. So that means as temperature goes up, solubility goes down. That means as temp goes up, I get less and less of this gas into this liquid. So doesn't it make sense that I would want to use something at a low temp to get more grams of this stuff in here? So I want to use a low temp to get more in, and I want to use high pressure. I want to use a high pressure to get it in there, and I don't even know how else to explain it to you other than you wouldn't use a low pressure to get a gas into a liquid. It's just, that should make a lot of sense that you have to have a high pressure to get it in there. In endothermic chemical reactions, energy is absorbed. And again, we can go back to this. Here, energy is lost. If I have the opposite of this, if I have an endothermic, here energy is gained. My products are higher in energy than my reactants. Therefore, I got energy from somewhere. It's absorbed as bonds are broken. This makes the delta H positive. Positive. Remember? Products minus reactants. Let's say this is 90 joules, this is 10 joules. 90 minus 10 is 80. It's a positive number. This is endothermic. Endo. All right, so we got her done in 2 videos. Not a lot of information here. I hope the information I went over on the board today was a lot more helpful than this. And again, if you have any questions, don't hesitate to use my remind or ask me before the test tomorrow. Have a good night, guys. Don't study too late.